continue on the chapter 4 on the CNC programming. Our topic we will cover on the basic programming. But before that, we will go through on structure of CNC machine and component, and then we will identify what are the work coordinate system in CNC machine, X, Y, and Z. And we'll do some simple part programming using G and Info. So, as an introduction, what is CNC machine all about? So, as all we know that the CNC machine, especially on vertical milling machine, is capable to machine cavities and especially uh, can be used to produce or machine mold and die in the industry. So for the construction of the machine, CNC machine, we have the major component as you can see here. The first one will be your machine interface, which is the brain of the machine. Uh, and then we have a spindle units, we have axis system, X, Y, and Z. And then we have a work holding system. You can position on top of the work table. So the table size, the work table will be very dependent on model of the machine, and the pricing of the machine will be delayed based on that spec on the work table size, the spinner speed, the distance of these axis can be traveled. So all depend on will be influence on the pricing. When we talk about the component of CNC machine, there are several components need to be clear. The first one is the control unit or the machine interface, where we can name as a brain of the machine or machine control unit, where it's responsible to translate the G-code program and translate to electrical signal that activate the movement of uh, the motors, the sensors, so that you can execute the machining process. And then we have a display unit, and then the MCU will be send the data to the driving system, the gear system, the drive motor system, the ball system will be activated. And beside that, we have a feedback system to detect the position and speed that being input correct or not. So the feedback will be sent back to machine control unit for detect any position will be displayed on the control panel in the machine interface. And to transfer the data, we can use clock system. We can use a pen drive. We can use also cable RS-232 to transfer the program from the computer. And for the loop system for the controlling tool movement, we have using AC and DC hydraulic servo motor being used, and the speed of this motor will be varied, and the control depend on the current and fluid. So the input to the comparator and directly sent to DAC and servo motor, and it will activate the gear system, and it will activate the ball screw or lead screw movement and finally translate to the movement of your work table. And then and on the side of the table, we have a position sensor to feedback the signal and send back to the comparator for any uh, uh, position of that table. To make a program, so we need to understand what are the work coordinate system or WCS in your machine. So need to be clear on this. So X, where is exactly X, Y, and Z. So X will be left to right, and Y will be front and back, and Z will be followed based on your spindle direction. So we can use also right hand rule to determine the those axes. And beside that three axis, we have additional axis for a more complex CNC machine like four axis and five axis. Will It will depend on the direction of the for example, your spindle direction, you're spinning along your spindle, so we call it a C axis, and the one that rotate along the y axis will be B, and A for the along axis. So you can have either four axis, five axis, or six axis system. Then where exactly we can position our work coordinate system? So the work coordinate system symbol will be, you know, denote as this round shape. So we can select either on the part of your page, so stop, or you can also position at your fixture or vice. So normally we choose for the work coordinate system at the fixture when we want to run for mass production, more than one piece. And we can use edge finder or probing in the labs. Okay, we have in our lab we use a probing or 3D system to determine the X, Y, and Z system. So normally in common practice, we position your WCS work coordinate system at the vertex or edge of your stock or model. So please go through the video, see how the procedure of finding the X, Y, and Z, as we can also refer in our lab session. For G encode mission motion, we have two kind of uh, thing that we can see from the G code. So G code will be define the motion of the axis X, Y, Z, and also your additional axis A, B, C. And M code specifically being used to control on and off functionally. For example, like coolant on, spindle on, okay? So and so on. So we use app code. So these are example of the typical example of G code programming, which is contain all the data about part and motion to move during the cutting operation. And the block is, we have a block numbers. You can set any numbers, and then we have your G code, and then followed by your coordinate system, and then your feed function, your spindle speed, and then you need to have your map coding. So this M03 stand for the spindle on, okay? And T1 is tool number. Depend on the controller language. For Fala, we define by tool number. For Simon, we use a tool name. So we have a, slight different in the deviation on the tool numbers, how we define the tool number, either tool number or tool name. So for the G code motion, we have uh, three type of basic motion. Either we have a linear motion to using for X, Y, and Z as fast as possible. This is used specifically for positioning our tool close to your piece. And the second one is to G01, specifically used for cutting. And therefore, we need to include with fit rate F. And the last one will be your circular movement, either clockwise or counterclockwise. For clockwise, we use the G03, and counterclockwise G02 and G03. So basically, this is these are the common G code that we use in basic programming. Okay, so the one that I think I haven't mentioned to you about is G41, G42, and G54. So uh this is the WCS or work coordinate system, as we mentioned here. Why we identify the position of your work coordinate system, we name it as a G54. So one you have more than one piece. For example, you have or you have one another one wise work holding system. So we have another one work coordinate system. So we have two work coordinate system. You can set more than one. So let's say two, we have another one is G55. You can name it either G55 or G56 and on the number of your part that you want to machine. So let's see how the program looks like. So these are the simple programming using G1. You can use, you have G1. Yeah. Okay. This is a G1, how we can use G1 to uh, activate the movement of cutting. So G01, as I mentioned here, we have, for example, our position now is at X 20. Okay. So, and then now your position as Y 20, and then the current position Z is 2. We approach your pace, and then we give instruction to bring down your tool to -2. So we need to put your feed rate. So remember for G1, you need to have your feed rate F function, and then followed by the second coordinates for this linear movement, x80, y80, and then for example, let's say I set as a -15. So the tool will move from point 1 to point 2 as a linear movement. So we can simulate this. I should have tried. So we have your, okay. So the second one will be circular interpolation. Circular interpolation, we have two options. For circular interpolation, we need to use vector x and y. So this vector we name as a x I. Okay, for x exists, j for the y exists. To specify the movement for this particular example, in this example, we have a G02 for the counterclockwise. The first thing, for example, your tool, okay, at this position, you want to bring it to the this position. So this your final position, your x will be x20, y35, and then to determine the vector I and j for the incremental coordinate system, we will measure from up to center. So this is up, okay, start point, and then you bring it to the center. So we only have y or j value. So since the vector is downwards, it will be a negative. So j will be -25. So this example is for incremental. The same thing apply for absolute coordinate system. Instead of we using incremental, we can also express as a absolute system where the only difference is we refer the point from absolute coordinate system. So this is absolute coordinate system. So for me, I recommend use for the circular interpolation, more easy to for student to use incremental coordinate system. So we have example here. Maybe we have some example program. So this is the program for the G02, or we can write down as G2. Then we can simulate. So the tool will move from, okay. So these are the program. And another one is cutter radius compensation. We can compensate your tool movement either to the left or to the right. It depends on the uh, cutting condition you require. So in order to compensate that tool, you can use at the G41 uh, before you express your coordinates. For absolute coding incremental, I think most of you are already familiar with that. Okay. So the basic programming, we talk about how to write the program G code. So the basic start with you need to set up your workpiece on your table. Okay. As mentioned here, as we can see, you need to secure your workpiece on your vise, and then your vise will be positioned on the table. Okay. And then we need to define the work offset coordinate system, your reference point, your absolute coordinate system. And then we start with program header. What is program header? So this is a program header. We need to define your stock size. We need to define your G54, your work coordinate system, whether on the vertex or the center of your stock. And then you define G17, your XY plane, and then absolute coordinate system. And then this is a metric system that you're going to use. So these are the heading, okay, program header. And then the technology, okay, the technology, we will define the tool number or tool name. And then we will define the tool chain, M6, and then set the spindle speed, rotation, and activate the coolant. So this is the next step that we need to establish in your program. So therefore, we have a MC, and then we have a tool number that we're going to use here. For example, in this one is T equal to factor 16, diameter 16. And then M6 stand for tool chain, and then we need to put on spindle speed, and then spindle on, spindle rotate clockwise, and then you activate the coolant. Okay, these are the one that under step 3 technology. And then next step, we need to uh, approach your tool, and then we need to retract for the safe position after you machine your product. So there are three major steps that involve here. Okay, set up a piece, program header, set your coolant, set your spindle on, tool chain, and then motion cutting, and then finally you retract for at a safety position. So example here, we have a simple string sorting process. Can use the ML 10, cutter 10. So try to practice this using this simple program using Tray. So we have let me check this one. Okay, the first one we approach, and then the two more over, and then we can introduce a repeat. We can repeat also for the multi-depth cutting. So these are example of multi-depth cutting. Okay, so the depth of cut is -2. If we want to implement 3 times the cutting, so we can use a repeat command to increase the depth of cut to total -6. And then please go through with the Shopmill. Also, we can use a Shopmill to produce that program as well. Okay, this is Shopmill. Okay, the first thing in Shopmill, you need to define your stock size, and then we define the counter. Okay, then we use a path vary. Ensure that you activate the left to the side G41. And then this is depth of cut -5. And then you can have a more simple programming using Shopmill. Okay. First step of multi-depth cut -1, -2, and so on. And followed by this example, exercise 2, please go through this exercise. As given the sample you could, please apply in your own train and try to practice the difference between implementation of incremental and absolute coordinate system for circular interpolation. Okay, so as we can see during your simulation, you may found that there are excess material exists. Okay, exercise 3, not this one. Exercise 2. Okay, this one. Okay, exercise 2. Uh, in this example, I use ML30. And looking back your note, we use ML 16. So when you use ML 16, you have excess material. So to counter that issue, we can increase the size or the diameter of the larger one. So during my example, I use a repeat function for multi-depth occur. For example, in this example, your depth occur is -1, 1.0 mm. So you can repeat this command by using um, to repeat cycle, you can use the repeat, and then you can apply from block number 110 to 200. So the program will be repeat the command and add P for the number of steps. Okay. So to make sure that your coding has a number, block number, you can use renumbering. Okay. For example, I have a program. Mm, Okay. This is without any number, block number. I can use renumbering, and then I have number. Okay. So that you can use a repeat command easily. For exercise 3, we will try to use some program guide G code for the spacing and also open pocket using different diameter. For spacing, we use a mill face mill with diameter 95. For the open pocket, we use a mill with diameter 20 mm. The starting material is 33, so our plan is to reduce the depth of the thickness to 32 using face mill. And finally, we will produce a open pocket using a mill with a diameter 20. So for face mill, since the operation will have a face mill cutter, so our face mill, okay, this is roughly our face mill, about 95 mm diameter. So means that we have to run more than once, okay, more than one pump. So we have to calculate that. Okay, so In order to determine the number of paths required for facing operation using diameter 95 to cover the whole 200 mm size, so we need to calculate using uh, okay, this one. Okay, so in this example, we assuming that the cutter engagement is 95%, or we call it a step over. Cutter engagement, we assume step over is 75%, or radiator cut step 75% to determine the cutter engagement length. So we have to time the diameter of your tool 95. So it means that the path, the distance between uh, the next consequent path is 71.25 mm. Okay, that's mean to identify the number of paths, we have to divide the width. Okay, the width of your stock 200 divided by 71.25. So what we get is 2.8, or 3 passes. Means that to use a MA95 with step over 75%, you have to run it 3 passes. So for 3 passes, mean the actual distance will be set 66.6 mm for cutter engagement. Okay, right. Step over, or we can call it as a step over. Okay. Okay, when you get the distance step over or cutter engagement 66.6 mm, so we can determine that uh, the distance. Okay, this dimension we can obtain here. So this is 66.6 between the distance from the first pass. Okay, and then we can calculate the consequent. We can determine the starting point. So starting point, we assuming that tolerance or offset is 10.0 mm. So that's mean the x will be 300 plus 10 plus 47.5. 47.5 is your radius of your face mill. And then for y, we already calculate here, is 66.6 from origin. So once we get x and y, then we can uh, design our program. So x will be uh, you can 357.6.5, and y is can set here 19.1. Okay, and then you can set the distance with uh for the next following pass. You can add another 60.6, so that tool will be okay, the tool will be offset. So this is the first pass, and then follow the second path. The distance will be uh, always 66.6. So therefore, in the program, you can see that we can add 66.6 by using incremental. We combine with incremental, so easy to us to specify the coordinates. And then the last pass is also we add 66.6 y distance. So that's why we have 3 passes. Okay, so this is for the face mill operation, and followed by the end mill operation. You can use the same method to calculate the distance, which is 14.3 offset distance for y. Okay, any question so far regarding this one? Please let me know. Okay. So I hope you can go through the notes and then let me know if you have any issues and uh, question regarding my lecture note. So we shall see again on the next session on the Fusion 360. We are using Fusion Camp to generate your G code program. Thank you very much for the uh, my class and your class. So see you again. Assalamualaikum warahmatullahi wabarakatuh.